I've recently released version 1.4 of the top-down-starter project. Both version 1.3 and 1.4 contain significant updates, which I'll be highlighting in this video. In the January release of version 1.3, I made substantial changes to the combat mechanics and animation playback, and version 1.4 introduces a new feature entirely, quests, which was requested months ago. I've been very busy lately, and I haven't been able to work on this in any real capacity since back in December, but I'm hoping to wrap this project up. If you have any questions regarding how things work in the top-down starter project, feel free to ask, and I will try to cover everything in writing and future videos. My next video will probably be a longer one, where I break down the entire structure and everything in the project piece by piece. Anywho, let's break down these 3 additions: quests, combat, and animations, in that order. Let's jump straight into the process of making quests. So the process is simple. Indeed, the entire system is very simple. It's quite bare bones, but it works, and you can expand upon it however you wish. In the scenes folder, there's a quest update scene that you can use. Let's drag one out into the scene. It's an area 2D node. All quest updates are done through these triggers, but you can of course do quest updates in a multitude of ways, like after killing or talking to an NPC, flipping a switch, or pressing a button. The quest giver script that comes attached requires a quest to function. It then also has a list of functions: give, update, or complete. Let's also create a new quest. I will press Ctrl+A to add a new node and type quest to get a new empty node with a quest on it. And here you can see the details that we need to fill in for the quest. Quest ID is supposed to be unique. There is no mechanic right now to ensure that it is, you'll just have to use a different number for each quest. We write a name, and objectives are an array. You can think of these as possible updates to the quest. Whenever the player moves through a quest update area, the quest will be updated to the next objective. And finally, a reward is in order after completing the quest. This quest will be persistent in the scene. The update areas will remove themselves after the player has triggered them, but the quest will remain until it's been completed. To properly set up a quest then, we need at least 2 of these areas. One that gives the quest, and one that completes the quest, and any number of updates along the way. Again, I realize that an area 2D trigger might not be the best way to do quests. There are many options for how you might want to progress. That will be for you to implement. How can we have something like an NPC tied to updating the quests then? Well, if we look at what these areas actually do, they simply call on the quest tracker that is attached to the player and tells it what to do. If you want an NPC to do that, you'll just have to call the player quest tracker, start new quest, update quest, or complete quest. You can call on this from anywhere. You have all the flexibility you need, I think. If you don't want the quest nodes stored in the scene itself, you could make a resource out of them and instantiate them into the scene when needed. 3 scripts are tied to the quests. The quest itself, that just holds the data. The quest giver that is attached to these areas, and again there is just a use case example which has 3 functions: give, update, or complete. We select the enum on the trigger, and it's matched to the corresponding function when the player enters the trigger. In fact, this entire match statement could be removed. The quest tracker on the player could do all of this instead, but I think it's easy to understand and expand for someone who wants to use this in their game. And finally, the player's quest tracker script. It tracks the current quest and carries a copy of sorts of the quest that it has received. That means it can only handle a single quest at any time. When triggered, we set the quest tracker text and make an announcement. The announcement is the big text that shows in the middle of the screen when a quest is updated. It uses tweening to fade the announcement in and out. We are not editing any sort of data outside of this class. We're also not changing the quest itself in any way. We read the quest given to us, and we can update through the different objectives. Really, we're just copying the text description from the quest. So again, quests, very simple, very malleable for anyone looking to use it and alter it. Firstly, I added a new attack. This new attack, the spinning moon kick, hits everything around us, which is much better than being able to deal damage only in the left or right direction as previously. However, gameplay considerations like this isn't really important. The game isn't supposed to be good, it's supposed to act as a lesson for you. You can see the 2 hitboxes here, and the 2 attacks are stored in these nodes. Our player has reference to these attacks, and depending on the input we adjust which attack we will be performing. Rather than nodes, you might want to save these more persistently by turning them into resources, saving them in a file or however you want to do it. Characters now have iframes after taking damage. This negates the need for manually checking if we can be hurt again by the same attack and such. The def logic has been moved to the parent base class, so our main classes are now almost empty. Most logic has been moved to the individual states, or is inherited by the base class. Previously, the characters used the animated sprite 2D node. With this release, we switched to the animation player. The animated sprite 2D node is wonderful to work with. It's very intuitive, simple, and you can get your sprites animated in minutes. But it might not be a great solution for game objects that need to interact with the rest of the world. With this update, I've rectified a mistake that I made and should have fixed at the beginning, and it's using the animated sprite 2D node. Now don't get me wrong, like I said, it's fantastic to animate your sprites, but that's all it can do. It animates sprites. Who knew? So both my character and the enemy have animations to play, tied to the finite state machine. So these animations just play, and we don't have any real control over them. So in the code we need to time the damage to certain frames in the animation. And since the animated sprite 2D node can only do animations and not affect anything else, that means I had to read from the sprite which frame it was currently displaying, and then turning the hitbox collider on or off through code. So the code is reading from and is being controlled by the animation. This worked fine for such a small project, but it's a really bad long-term solution. And honestly, I can't believe no one has pointed it out yet. Playing a sprite animation and then trying to read from it through code like this is one of the ways of playing and controlling animations, and it's probably the worst option. The other alternative would be using the animator, and of course this won't be news to anyone. I believe the normal way to do it would be to have a sprite sheet with your animations and letting the animator change the H-frames in the sheet. This would be a good way to do it. Unfortunately, I had all of the singular images in the project, and I'm too lazy to make a sheet of it now. So the third option, which is also really good, is that the animator is incredibly powerful. It can animate not just sprites, but almost anything, including our animated 2D sprite node itself. So how I've set it up is like this. The animated sprite 2D has all of the frames for the animations, just like before. I didn't change anything. The animator can now animate the animated sprite 2D node, now that's a mouthful, and move through its already set up animations. It grabs the individual frames of those animations in order and displays them. So it's really just taking manual control over the animated sprite node. It can then also animate other things, such as the hitbox, turning it on and off at the correct frames, which means we only deal damage on those frames specifically. Each animation can have its own hitbox, fitting each independent animation with 0 lines of code. And as a programmer, I have to say, the less code we write is typically the better. Another useful thing is that the animator can call functions in our scripts. I took advantage of this by having the enemy attack animation make a sound when the weapon hits the floor at the end of the animation. This is the same as an animation event in the Unity game engine. In summary, the animated sprite 2D node is fantastic for quickly setting up sprite animations. It's incredibly easy to use, but if anything more complicated needs to be done, such as synchronizing the animation with particles, sounds or code events, the animator has to be used, and it's very flexible. In other news, the project now has more comments, is generally easier to understand, and has custom icons for the individual states, the FSM component, and quests, to make them stand out from all the other nodes. And in the project list, we now have a little starter project tag to stand out from your own projects. Until next time, thank you so much for watching.